Today's lesson is on dilution. Now I have a personal example of dilution. As you know, I'm not drinking my Pepsi anymore, and in the morning I have cranberry juice. But the cranberry juice is pretty strong, so I find I like it better if I take about a half a glass of cranberry juice and I dilute it with water about equal amounts. And so the cranberry juice then is dispersed in a larger volume. We call that diluted. And it has less concentration than it did before. And I like it better that way. So now if we think of these three squiggly lines as the cranberry part of the juice, we have them dispersed through a larger volume of material. Kind of erasing and rewriting these. So now, as you can see, it is less concentrated than it was before. And you've probably done some dilution yourself with juices or beverages of your own. And we do this in chemistry. It's actually very useful because we can take a more concentrated, what they call a stock solution, a bottle that we would store in our prep room, and we can make several other concentrations from it by just taking some of the concentrated material and diluting it to the volume and concentration that we want. So here's an example of doing just that. What is the new concentration of a 0.20 molar sodium chloride solution? So let's say I have this stock solution in the back. If I take 25 milliliters and I dilute it with water until it's 50 milliliters. And once again, you could probably do this math just in your head. You take 0.20 molar, you take 25, you dilute it up to 50. So what happens to the concentration? It is half the concentration that it was before. How could we show this mathematically? Well, I start with 0.20, we're still in our red. Well, we'll leave it red. 0.20 molar solution of sodium chloride. And I took 25 milliliters of it and I diluted it to 50 milliliters. So it's 1/2 the original concentration, and I have 0.10 molar at the end. So there you have the mathematics behind a very simple problem. I have a concentration. It is now half as concentrated because I took 25 and diluted it to 50, what it was before, and so I have 0.10 molar sodium chloride. So if I want to use this for more complicated problems, it's easy to use something what we call a generic equation. So instead of using the specific numbers, I'm going to turn those into letters and symbols that I can use in other problems. So what did I have here? Here I had 0.20 molar sodium chloride. So we're going to use the letter C to stand for concentration, and I'm going to give it the number 1. So that was the original concentration, and I multiplied it. What did I multiply it by? 25 milliliters. That was the original volume, so I'm going to call that volume 1. And then we divided that, wrong direction. We divided that by 50 milliliters, which was the final volume. So the final volume, we'll call that volume 2. And that gave me the second concentration. So here we have a generic equation for what we call dilution problems. I take some concentration. I take some part of it, some volume. I dilute it so it has a bigger volume, and therefore it has a new concentration. And we can talk a little bit about the values of these. This is the original, so concentration, and this is the final concentration. So C1 is always greater than C2 because I'm diluting it. So the new concentration is smaller. And I take some small amount of volume and I make that bigger. So the second volume is always greater than the first volume. And sometimes you see this in a textbook, not written as this, C1 times V1 over V2 equals C2, but they multiply both sides by V2 and get C1 V1 equals C2 V2. And notice we've been doing a lot of unit analysis problem, and here we're going to actually use an equation just because it's so simple instead of unit analysis, but you could go back and do this as unit analysis. And even when you use an equation, you can find out that units cancel. So I have milliliters cancel, and I'm left with molarity. Now, something important about canceling these units, that this volume and this volume have to be in the same units. So they either have to both be milliliters or cups or pints or liters, but whatever you use for one volume, you have to use for the other volume. The same thing with the concentration. It doesn't matter what concentration you use, they just have to be the same. So if you're using moles per liter, molarity, then the answer is in molarity. So it doesn't matter what volumes you use, or units for the volumes, or units for the concentrations, as long as they are the same. So we do have to remember that, because the units still have to cancel, even if I use an equation to solve it instead of unit analysis. So let's use this equation to solve some problems. So here we have a problem. How many milliliters of 0.65 molar HCl is needed to produce 1.0 liter of a 0.10 molar HCl. So I'm going to dilute this from 0.65 molar down to 0.10 molar. And I want to know how much do I need to start with to get this concentration. So I use my generic equation, and when you're solving these on a test, write the generic equation down first so I can see what you've chosen to do before you make your substitution. You also need to decide what variable are you looking for and what variables are you given. So we have to decide, am I looking for concentration or volume? So how many milliliters? Well, milliliters is a volume. So I'm solving for a volume. So am I solving for V1 or V2? Well, how many milliliters of 0.65 molar HCl is needed? So that must be the starting volume, and this must be the starting concentration. So I plug those in. I have 0.65 molar times V1, I don't know what V1 is, equals the second concentration, 0.10 molar. And remember, concentration 2 has to always be less than concentration 1, times the volume, which is 1.0 liter. And so this volume always has to be bigger than this volume, or V1. So the answer is going to be something less than 1 liter. So I solve for V1, divide both sides by 0.65, and I get an answer of 0.15. Now be careful, what are the units? Well, the molarity, or the capital M, is going to cancel out, so the volume is going to still be in liters. So I have an answer of 0.15 liters, but be careful, the question asks for milliliters. So I'm not quite done yet. I have to convert this answer to milliliters. So I have 1 liter equals 1,000 milliliters. And now my actual answer is that times 1,000. So I have 150 milliliters. And we had 2 significant figures, so that's what we have. So if I take 150 milliliters of 0.65 molar and dilute it to 1 liter, I will end up with a 0.10 molar concentrated HCl. And though these are typical problems that you actually have to do in a laboratory to make solutions that we use every day. What other kind of questions might you be asked when dealing with dilution? Well, sometimes we want to know how much water is added. So if V1 equals the initial volume of your solution, and V2 equals the final volume, how much water did you add? Think about it for a second. Well, the final volume minus the initial volume tells me how much water I added. And another way you can think about it, ooh, way too many D's. Let's undo that. All right. And you can think about it this way too. The final volume equals the initial volume plus the water that you added. All right, so let's take this information and look at the next kind of problem you might be asked to solve. How much water should be added to 100 milliliters of 0.25 molar sodium chloride solution to make a 0.10 molar sodium chloride solution? So once again, you're in the lab, you have a bottle of 0.25, but you don't need 0.25, you actually need 0.10. How are you going to make that? Maybe you only have 100 milliliters of this 0.25 molar solution, and you're going to dilute it and then use what you have. So once again, I write the generic equation down, C1V1 equals C2V2, and then I substitute and solve for the missing one. So 100 milliliters of a 0.25 molar sodium chloride solution is what I have initially. So I have 0.25 molar times 100.0 milliliters equals the second concentration, that must be this, 0.10 molar, and the second volume. Now notice here the question really asks for how much water is added. To solve for that, I first have to know V2, and then I can plug it into V2 minus V1 and solve for how much water is added. But first I have to solve for the final volume. So I divide both sides by 0.10 molar, and the m's are going to cancel out, so I'm going to get an answer in milliliters. 0.25 times 100.0 divided by 0.10 gives me an answer of 250 milliliters. But that's not what the question asked. It didn't say what is the final volume. It said how much water do I need to add. So V2 minus V1 equals the water. So the final volume is 250 milliliters. I started with 100.0 milliliters. And now watch this for sig figs. I am subtracting, so I have to follow subtraction rules. This is only good to the tens place. This is good to the tenths place. So I get 150, but not 150.0. I can only do ones to the tens place. So about 150 milliliters. So let's think about this. How much water should be added? So if I have 100 milliliters of a 0.25 molar solution, and I add 150 milliliters to it, I will get 0.1 molar sodium chloride instead, and I'll have a total volume of 250 milliliters. So there you have it, problems dealing with dilution. Hope you've taken notes and try some on your own. Thanks for listening.